Hello. Today this video is for Scientific Notations Guide. So we're basically going to run through what a scientific notation is, because in chemistry we're going to be dealing a lot with numbers that are in scientific notations. So it's really important that we understand what that actually represents when we calculate them or when we are converting them from standard form. So scientific notation is just what it is, and the bare bones is a quick way to write really large or really small numbers. It's easier to digest instead of having to write 0.00000482 instead of writing and saying all of that out loud, to just say it in scientific notation. So the purpose is to be simpler. So it might be more confusing to start, but the more practice you get with it, really it's the easier or simplified way to go when looking at really big or really small numbers. So there are two forms a number can exist in. We deal primarily in standard form. With math, or everything you've done up to this point generally has been standard form, just the number written out as it is. So we can take this number in standard form and convert it into scientific notation. Okay. For scientific notation, there's a general setup. And we can kind of use this and this as our two examples as we talk about it. So in scientific notation, you will always have one non-zero number followed by a decimal and two numbers. They can be zero, or they can be non-zero, it doesn't matter. Followed by a times 10 to the, and then some type of exponent depending on the number. Okay, so for example, here we have the top one. We have 9.83, a non-zero number to start, 9, followed by two numbers. Again, they can be zero, they don't have to be. Followed by times 10 to the 9th. So that's telling me that's a really large number. This one down here is 2.91, right? So it's always going to be a number, a decimal place, two numbers, and then times 10 to the something. Okay, so whenever you see something with a positive exponent, that means it's going to be a very, very large number. The larger the exponent, the larger the number. So if we look at the problem here, we have 8.42 times 10 to the 5. Now for this, what we need to do is basically move this decimal over 5 places. And we'll get to that in a second. But basically that's telling us, this exponent here is telling us that's a large number. It's not 8.42, it's actually 842,000. Alright, so that exponent is the key to understanding how big or how small a number is. Small numbers have negative exponents. So here we have the same start, 8.42 times 10, but here we have negative 5. So that's telling us that that's a really small number. It's actually telling us it's between 0 and 1. And if we look at it, it's 0.0000842, right? So that's a big difference between numbers, right? And all we did was add a negative exponent, or change that 5 to a negative 5. So using the correct exponents is key in scientific notation. Okay, all numbers less than 1 have negative exponents. This will come up frequently in chemistry because we are dealing with atoms and molecules that are really small. So we'll constantly be seeing things that have sizes or distances or shapes that are this small. Okay, so we want to be clear about what that actually means. All right, negative exponents are really small numbers. They're not negative numbers, they're just between 0 and 1. Right. So we're going to do some examples here. At any point, if you need to pause the video or if you feel confident in understanding it, just feel free to jump ahead. Let's get started with the first one. So write 0.0003241 in scientific notation. So we need to start with our first non-zero number, right? So we know that's going to be 3. right? Because if we're going this way, this is our first non-zero number. We put in our decimal, and then we add our next two numbers to 4. Right? And this is similar to significant figures. We have to look at that number before 4 or after 4 to see if we round up or down. 1, that means we round down. So we just keep it at 4. So we add our times 10, and then this is where we need to figure out our exponent. We need to figure out how far we move that decimal. To do that, we just start at the decimal and go until we get to the front of 3. So we're going to take this decimal here and move it over 1, 2, 3, 4 times. Okay, so that's going to go up here. Next, we need to figure out, okay, this was a really small number. And in this case, we went left to right. We know really small numbers have a negative exponent. So it's 3.24 times 10 to the negative 4. Okay. Let's do another one. Write 8,234 in scientific notation. Again, start with your first non-zero number, decimal, and then next two numbers. All right, that 4 is telling us to keep it at 3. We're rounding down. And then we have to figure out how many decimals we move over. So I'm going to rewrite that number, the problem over here. Now, the decimal is not being shown here, right? But we know that if it was, it would be right there, right? So we need to move this decimal over to our scientific notation, which is right in front of, or behind, I guess, the 8. So we have to move it over 1, 2, 3 times. So that means that's our exponent is going to be 3. So do 8.23 times 10 to the third. Okay, now we have a negative exponent, right? 9.87 times 10 to the negative 3 in standard form. So I would just write out the setup, and then always think about this before you start moving the decimal. Sometimes people just move it, and I'm guilty of this too. Sometimes you just move it without understanding what you're doing. That negative exponent is telling us it's a really small number. Right? So if we go this way, that's going to make a really big number. So we don't want that. And it's always going to be a small number between 0 and 1. Okay. So knowing that negative 3 is going to make it a small number, we move it over 1, 2, 3. So that's where the decimal is going to go. And we just fill in the spots with zeros. And then we just always need to make sure we have a 0 in front of the decimal place as well. So that 9.87 just becomes 0.00987. That's our answer. All right, next one, write 1.29 times 10 to the 5th in standard form. Again, look at that exponent to tell you which way you're going to go. This is going to be a really large number, right? It's a positive exponent. So we take that decimal and we move it over 5 times. 1, 2, 3, 4, 5. And any spot where we do not have a number, we just fill in with a 0 as like a placeholder. So our number now is, let's see, 129,000. That's a really large number, right? All right. Next, we have this really big number that's 56,103,293. Write that in scientific notation. So again, I'll just write it out so I can a little bit bigger. Right, we know there's a decimal that exists right here. We don't actually need to see it to know that that's where it would be. And we have to get it to this point, right? Because that's our setup is always going to be one number followed by the next two numbers. So in this case, 5.61 times 10 to the, and this is where we have to count it out. So we are moving this decimal place over 1, 2, 3, 4, 5, 6, 7 times to get to that spot. So this would be 5.61 times 10 to the 7th. That's a huge number, right? All right, so then kind of like the opposite, write 3.29 times 10 to the 5th in standard form. So we're going to take this and move it over 5 times. 1, 2, 3, 4, 5. Fill them in with zeros, and we get 329,000, or 329,000. All right, a few more just for more practice. Write 0.0000321 in scientific notation. So this is a really small number, so we know this is going to be a negative exponent. So maybe we can zoom in here. Yeah. So let's see how many times we're moving that decimal place over, right? We need to get it in front of that first non-zero number. So we're going to go 1, 2, 3, 4, 5, 6. So that ends up being 3.21 times 10 to the negative 6, right? It's negative because we are representing a very small number here. We went over 6 spots. Next, write 9.83 times 10 to the negative 8 in standard form. All right, so hopefully you can tell, based off of that exponent, this is going to be a very, very small number, smaller than the one we just did. So we just start here, make sure you have enough space, and we don't want to go to the right, because that would make it a really big number. So just always ask yourself, are we making a really large number or a small number? In this case, it's small because it's a negative exponent, so we have to go over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So we put the decimal here and fill in the zeros wherever there's like a curve. And then just always make sure you have a 0 in front of the decimal place. So that is 0.000000983. So hopefully you can kind of start to see it's a lot easier to write it like this, 9.83 times 10 to the negative 8, than it is to write it like this. Because this is just kind of lengthy, and it's just a lot easier to get your zeros mixed up, right? It's a lot easier to write 6 zeros when you should have written 5. So we always just keep it, a lot of times we just put it in scientific notation because it's easier to just write out and less likely to make mistakes. Okay, so this is kind of hard to do on an iPad, but calculating with scientific notations. You're going to be using your non-graphing calculator sometimes to either multiply numbers in scientific notations or divide them or add them. Don't be intimidated by that because you just have to make sure you put parentheses around your scientific notations. So I'll try to write out the steps for what you would need to type into your calculator when you do something like this. So for this problem, it says, what is 8.10 times 10 to the second times 9.82 times negative 7? So first, don't do this by hand. Just always you have the calculator, use it. So in the calculator, I would write parentheses 8.1 times 10, and then this is where it will differ based on the calculator. Some will have an exponent. It'll say like times 10 to the x. Mine has this E button, and it's in blue. Sometimes it's EE, or sometimes it's just a single E. But those E's mean exponent. Okay, so I do times 10 to the E, and you might have to use that second button if it's in blue. And 2. Right, E2 is the same thing as 10 to the second. Okay, and then times, parentheses again, 9.82 times 10. What do you think this is going to be? You just type in E, and then you should have a negative value there, negative 7, end of parentheses. And if you do that, let's just see here. Just put it in my calculator real quick. you should get 0.0795. All right, we have 3 sig figs in both. So our answer is going to be 3 sig figs. We could also rewrite this in scientific notation, right? Or, so instead of 0.0795, we could say it moves over 2 spots. It could be 7.95 times 10 to the negative 2. Right, these are the same numbers. All right, that was a little tutorial on scientific notations. I hope this was helpful. Bye, guys.